showing you what a force is.
Oh, you mean
It's a
like
push
a push? Okay.
Or a pull.
And a pull. Okay, got it. You're right. Force is a push or a pull.
Let me do it again.
No, I'm going to, please. For example, like gravity. Can you demonstrate gravity, please? Nice. Or like, wait a minute here, wait a minute. Like a magnet. Here, we're going to do extreme close-up. Watch. Oh,
wow.
yeah, okay. Or contact force, which, oh no. Yeah, it's like that. Yeah, it's like that. So that would be force. A
push or a
pull. Okay, good.
Okay, but forces, you can have different kinds of forces. Two kinds. You can have balanced or unbalanced.
Okay, balanced. All right, good, balanced. So that means the forces on one side equal the other side. And then we have unbalanced. Like that. That would be unbalanced.
Okay,
oh, I like that part.
Okay, so the balanced force does not change the object's motion. The object is going to stay where it is. Okay. So in this picture we have a force pushing on the car this way.
And a force pushing on the car that way.
Those forces are the same, so the car is going to stay still.
Wait, let's use our demonstrations part of science. Okay, here we go.
So if we're pushing on the car.
If our forces are balanced, the car will not move. However, if they're not balanced, if one force is stronger than the other, it will start to move. Okay?
So if it stays still, they're balanced forces.
So
the object's motion doesn't change.
In fact, if there's, yeah, okay.
Right?
Right.
Okay. So the opposite is the unbalanced.
Okay. And with this is a little harder because friction, we live where friction is and gravity is. Because if I actually was in space and I pushed this car in space, it would just keep going and going and going and going like the Energizer Bunny, except it would just keep going because there would be no force to oppose it.
Stop it, right?
So these forces cause the object to start moving and to stop moving. So that the car would just keep going in space until it hit some other object, and then that was exactly the same amount of force, and then it would cause it to stop. If it was more force, it would cause it to push the other way.
Right, to change its direction.
Or change direction, like if it was not exactly to one angle, could change the direction. Yeah, exactly. So that's the way unbalanced forces work. So when in opposite direction, the box moves the direction of the larger force. So we have a larger force, in this case the car.
Yeah.
Okay, so the car would move that way because I have a bigger force pushing that way. Right? All right.
And in this one, if you don't see the force over here and you just have a force pushing this direction, it's obviously going to move the direction of the force.
Right. So it's going to have a direction on
the
force. Okay. Good. That makes pretty much sense.
Yeah. Okay. So while you have these balanced and unbalanced forces, you could have work being done on the object. How do you know if there's work being done on the object, though? Well, if there is work, the object will move some direction if there's work being done.
In fact, if we do the formula is force times distance.
Right.
So no matter how hard I push this wall, it doesn't move any distance, so there's absolutely no work being done. But if I just barely have a little bit of force, but I move this car, then there's work being done on the car because it is moving. So it's got to be force times distance. So you have to have some distance for there to be work to occur.
Right. So you need to remember, work is not done when there is no motion. If the object does not move, there's no work being done.
And you should remember that from last year.
Yeah, that's just kind of reviewing. Oh, that is a big
Inertia!
word.
Inertia. Objects want to keep doing what they're already doing. If they're at rest, they stay at rest. If they're in motion, they stay in motion.
What's that mean?
Well, the bigger the mass of an object, the harder it is to move or to stop. Okay, so if I have more mass, let me see you move me. She can't move me because I have more mass than she does. Okay, well, hopefully.
Well, think of it like this. If your mom asked you to move the refrigerator and she asked your cousin to move the microwave, which one's going to be easier to move?
The microwave.
The microwave, because
Yeah.
it's smaller. So the
Right.
bigger the mass, the harder it is to move.
That makes sense.
Yeah.
Okay. So, unless acted on by an unbalanced force, moving objects will keep moving, and objects at rest will stay at rest. It's kind of like we were saying, you kind of have to think about it in space, because we always have forces here on Earth that are slowing us down. We have gravity
Yeah.
and friction. So it doesn't really work as well on planet Earth, but if you were in space, if I push this in space, it would just keep moving, and unless it had another force opposing.
Newton's first law. An object at rest will remain at rest, and an object in motion at a constant velocity will remain in motion unless acted upon by an unbalanced force.
If this rabbit was in our car of science and we moved him, he stops because there is a force. We have the force, the mass of the book, and if you'll notice, the book moved just a little bit because there is a little bit of mass here and a lot more mass there. We'll do it again. And you can see it stops the car because there's a force
So
opposing.
if this wasn't here, the car would keep moving.
It would keep moving.
Okay.
It absolutely would keep moving.
Okay.
Okay.
So what
And
happens?
we notice we have our rabbit strapped in for safety,
Safety
right? Because you always want to buckle up.
You do. What happens if you don't buckle up?
Well, by buckling him up, you're making him part of the car. Okay. By unbuckling him,
Not safe.
it's not safe, and here's why. He is not going to be part of the car. So we'll see what happens when an unbalanced force is placed on the car, but not on the bunny.
Okay.
So we want to do that now?
Yes.
Okay, here we go. You ready?
Oh, the bunny kept
the bunny
moving.
fell out.
Do it again. Do it
Okay,
again.
You do it. You do it.
Okay.
Show me how. Okay, make sure it's just not me.
Okay.
Here we go.
Be safe.
Okay, so why did the bunny keep moving?
Well, probably because objects in motion stay in motion.
And he was in motion. He was in motion.
But nothing was there to stop him.
Right, so he kept moving even though the car stopped.
This force stopped the car.
But it did not
But it
stop the
didn't
bunny,
stop the bunny.
so the bunny kept on moving.
That's sad for the bunny.
It is sad
He
for
should
the
really
bunny.
wear a seatbelt.
You really should wear a seatbelt. Oh man, every time.
You should buckle up for safety.
Buckle up for safety, yeah.
Yeah.
Okay, so is that all we have?
That's all.
Okay, well, the last thing is remember, stay safe, buckle up,
Buckle up.
and
It's the law.
bye.
Bye.